Hello everybody. Today you're doing ionic formulas and naming. Okay, you're going to be using the oxidation numbers, your charges, for transitional metals, regular metals, and you're going to have already a chemical formula and you're going to write the name of that chemical formula. Okay, we're going to do some practice runs right now using group A metals and group B metals. Your group B are your transitional metals. And then towards the end, I'm going to try to put you guys in breakout rooms so you can kind of work together. Okay? Okay, guys, this is actually in your Schoology. And if you can print it out, go ahead and do so. But this is going to help you do the actual name of a compound. Okay? So by looking at this chart goes with the actual first element of your compound. Okay, so let's do an example. Okay, so let's say we do something like CaBr2. Okay, the first thing you're going to look at is that very first element, the one on the left side. So this element, is it a metal? Is it a non-metal? Okay. Now calcium is a metal. Then you're going to decide, is it a group A metal or is it a group B metal? Now what do I mean by group A and group B? Okay, so when you have your periodic table, this whole section, your S section, and your P section of that periodic table, these are your group A's. Now, when you look at your transitional metals, that is the D section and your F section of the periodic table, all of these are transitional metals, and these are intertransitional metals. This is your group B. Now, there are exceptions to the rule, so your SN, your SB, your BI, and your PB, these, even though they're in this A section, they function like a group B. I would pause this video and label your periodic table or take a screenshot so you can label that for later. Okay, so now calcium is right here, so it's in the group A section. So what is your notes? Now I promise you, if you follow these notes with the first element, the very left one, you can never go wrong. So it's a group A metal, you do nothing to it, you just name it. Ca is calcium. And Br comes from over here, and that's bromine. Remember that your bromine changes to bromide. So that last word always ends in IDE. This means it's an element that comes off the periodic table. And that's it. That's your name. Let's try another one. Okay, now let's try a different one. Let's do Al2O3. Okay, now remember these numbers are what crisscrossed. When you originally had aluminum, it was a +3. Oxygen was a -2. They do not cancel out or reduce, so they crisscross. Anytime you have a chemical formula, that means your oxidation numbers already crisscrossed. It's the answer. So what you're trying to get is just the name. Okay, so now aluminum is your first element, is the one on the left. Aluminum is right in this boron family. It's right here. Okay, so it's a group A metal. What do we do with group A metals? Nothing. You just name it. So it's aluminum. And then oxygen changes to oxide. That's it. That's all you do to it. Okay, now let's use something that has a polyatomic ion. For example, let's use strontium phosphate. Okay. All right. So now strontium, this first element, it's a group A metal. So you just name it because all you have to do is name strontium. And PO4 is over here with phosphate. PO4 with -3, and yes, that 3 went down, so it's phosphate. And that's it. You're using a polyatomic ion with a group A metal. Okay. Okay, so now let's use a polyatomic ion with a transitional metal. So this first element, iron, is a group B because it's a transitional metal. So metals that are in the middle use Roman numerals. Since you have this number originally came from the iron, Fe is iron, and your original charge was 2, so you have a Roman numeral 2. OH comes from your polyatomic ion sheet, and that is hydroxide. It should be here somewhere. There it is. Okay, that's hydroxide. And that's it. This is your chemical name. Okay, so now let's do another one. Let's say you have something like, let's do copper with sulfur. Now, let's erase this part. Okay, now copper, is that a group A or is that a group B element? Copper's in the middle of the periodic table, so it's a group B. So yes, you're going to need a Roman numeral. So you have copper. And let's figure out what that Roman numeral should be. Sulfur is going to be sulfide because it comes right off your periodic table. So remember, anything that comes from your periodic table is going to end in IDE. It's a binary compound. Now, look at your periodic table and what used to be the charge for sulfur before you do your crisscross. Sulfur, and let's see these over here. Sulfur used to be a -2. So what did copper have to be? Because since we don't have that 2 down here, something had to cancel that number. And we don't have a number over here, so that means you had to have a +2 charge for both of them to cancel. Because remember, if you have the same oxidation number, they cancel out. Therefore, your Roman numeral is a Roman numeral 2. So your name would be copper 2 sulfide. And that's your chemical name. Okay, so now let's do another example. Let's take something like Na3P. Okay, so Na is a group A metal. What do we do to group A metals? Nothing. We just name it. So this will be sodium phosphide, because remember that comes from phosphorus. So phosphide, it has an IDE ending because it comes from the periodic table and it's a binary compound. Okay, so now let's do something like let's do nickel. Nickel. And let's do, let's say a 2. And let's do SO4. with a parentheses 3. Okay. All right, so this first element, nickel, this is in the middle of the periodic table, and it's a transitional metal. Therefore, it's a group B. What do we do to group B's? We do a Roman numeral. So nickel. Now, what used to be the charge for nickel is your Roman numeral. SO4 is one of your polyatomic ions, which is sulfate. So you have sulfate. There we go. Okay. Now, what used to be the charge for nickel? What went down? That 3 is what used to be the oxidation number. So that is going to be your Roman numeral. Okay? Okay, let's do something now that's going to actually change or reduce. For example, like PB. And let's use sulfate again. Okay. Now, how do we look at this? Well, remember PB is lead. And you can find the names of these elements on your periodic table. Lead is one of those exceptions. You know what? Let's go ahead and do this on a different sheet. Okay, so now remember that lead is one of your exceptions over here. It is in group A, but is one of those exceptions that you have, PB. So that means it's going to function like a group B. Okay, so now PB is one exception, so it's going to function like a group B. Now PB is lead, and therefore it's going to have a Roman numeral because it's a group B. SO4 is sulfate, and that comes right off your chart. So you're going to just write sulfate. However, how do we figure out this Roman numeral? Well, sulfate has a -2 charge. But do we have a 2 over here? No. So what had to be above, what was the charge for lead for you to not have that 2 there? This means that you had to cancel something. So you must have had to cancel a +4. That 4 gets reduced to a 2, and this 2 gets reduced to a 1. That's why you don't have anything here, and you have this 2 down here. Okay, but your original oxidation number was that 4. So you're going to have a Roman numeral 4. And that's how you figure out a name for a reduced compound. Okay, now you need to write down these chemical formulas or take a screenshot, because I'm going to now put you in breakout rooms and you're going to write the chemical formulas in here, and you're going to discuss with each other what the name should be. Once you're finished with all of these, you're going to show it to me to get credit, and then you can do the assignment from today. Okay, but this itself is going to count. All right, work together